Hi, this video is about Commodore 16 repair. As you can see, I've received 3 of those. Well, it has keyboard errors and this one gives me just black screen. And this one has something else. If you ask what can go wrong in these computers, let's say that way, anything. Mainly the CPU, the PLA, and the TED itself. But since a while, there is a solution for each of them. Okay, so here we are. Let's open the box. What is inside? With single hand, it is not that easy. You can see I need to disconnect the keyboard. And there I need to remove this. It's a kind of paper. This is one of the C16s. So what can go wrong? The CPU. This is the TED chip and the PLA. Most of the case, those are the reason behind a non-working C16 or +4. And since this is a C16, if I want to expand it to 64 kilobytes, I have to replace these 2 memory chips. But what can I do if any of those fails? Well, for the CPU, I have 2 options right now. This is an older solution. This one can use a CPU from Commodore 64. And then I need to replace this kernel because otherwise it is not possible to load programs from the tape. But there is a better solution. I have it here. This one is using an original 6502. And there are several latches. And then it can substitute this original CPU. The only problem with this one, there is a socket. So it will work very well in the C16, but if I would like to use it in a +4, since the casing of the +4 is not that high, there are space constraints, so it is better to solder the CPU directly on the PCB. Okay, so this is for the CPU. Let's jump to the TED. For the TED, there is this FPGA TED solution. It has even an HDMI output. I will run few demos with this one. And I have an additional board here, which can help in the memory upgrade, because this one contains the 64 kilobytes memory. I just need to insert this one into the socket here, and then the TED substitute on top. So that way I can have 64 kilobytes of memory and the TED replacement at the same time. But this one has the same issue with the +4 or the 116, because here I have plenty of space between the PCB and the keyboard, but in the +4 the space is really limited. So I don't know if it is easy to fit them. Of course, I have to bend few capacitors. It was in the description because the PCB is a little bit longer than this chip. But let's see how it will work. And finally, there is the PLA. I have this PLA replacement. It is soldered on the board, so I can easily use it in a +4 or any of the TED series machines. But let me check the errors. So I connect this PCB and the others to my monitor, and let's see what kind of errors do they produce. In case of black screen, most of the times these 2 are the problems, but PLA can also cause different kind of issues. For example, I've seen gray screen, also flickering characters, so they are not my favorite ones. As you can see, I've replaced the TED. It is because when I turned on this machine, I got just a black screen. So my assumption was either TED or the CPU. So I replaced the TED because since I want to test this FPGA TED, it made more sense to replace this one than the CPU. But now I have a different error. Let me show you. I guess here the problem will be the PLA, or this is what I hope so. So I'm replacing this one as well. I guess I was right. It was the PLA. With the replacement, it is working pretty well. Let me show you the new PLA. So in this machine, I've already replaced two chips, original chips. So this is the FPGA TED and right now the PLA. That's it. It is working now. I just need to test the 64 kilobyte expansion and that's it. Okay, so now the 64K expansion and the FPGA TED is on top of each other. I'm pretty sure it won't fit into the case, but at least I can test it. So the next step is to connect it to the grabber card, load some programs, demos, whatsoever, and I think I will use the digital output here. I'm really interested how it will work out. Okay, I made a test. It can fit, but just barely, into the C16 case. As you can see, the digital output of the FPGA TED is touching the keyboard. So the sandwich can fit somehow to the C16, but for sure it is not suitable for the +4 or the even smaller C116. As you can see right now, I've expanded it further. So there is this small card. This is an SD card adapter for the TED series. This is called TCBM2SD. And it is emulating or partially fully emulating. I haven't tested it yet, so this is my first time. The floppy drive, which was for the TED series. Theoretically, I can switch between the images with these two buttons back there, as you can see, so those buttons. But there is also a software solution. Let me turn on this computer and switch over to the capture card screen. The video output of the FPGA TED is quite good. It is a bit pixelated, but this is what I expected. If you do not like how it looks like, it is possible to configure it. As I start the configuration program, the first page is providing hardware information like the board revision, the TED core revision, and I think the most important is the firmware version. In the next versions, we can expect new features. On the General tab, you can see sign of those new features. I think it will be possible to select a kernel and basic version later on. Right now, it is not working. Based on the designer's blog, he is developing the SID chip emulation. I'm looking forward to it. But if you are not happy with the video output, it is possible to fine-tune it on the next page. You can switch the video mode between PAL and VGA. It is also possible to turn on the scanline effect and change the aspect ratio. I also played around with the color palette, but at the end I just switched back everything to the default. While I played around, I also noticed that it is very important which program or monitor do I use for the FPGA TED. I recorded the same screen with two different programs at the same time. On the left side you can see the OBS, while on the right side the native program for the capture card. I prefer the sharper left side, but it is really up to you which one do you like. I would like to talk about the SD card interface as well. So this one is emulating the Commodore 1551. It is very fast, and there are two different ways to load programs. The first one is very simple. You just load the content of the directory and then load the program itself. The second one is to emulate floppy disks. So you can use D64, D81, similar to other floppy emulators. If you have a game, it is possible to collect all the floppy images into one folder and then switch between those images, disk A, B sides, with the two buttons at the back of the card. It is very handy if you have more than 20 or 40 or 80 images on the SD card. Unfortunately, I was not able to figure out how to change between the directories from BASIC, but there is a nice program which is providing a menu for that. There was only one hiccup. I downloaded all the images with games from GitHub, but what I found in the zip file, it was not working for me. Luckily, it is possible to download multiple versions, and I managed to find a working one. It is working pretty well. As you can see, I can move between those directories. I can even select one of those disk images and even start the program by hitting the return. It is a very nice function, I really like it, and I played around with the provided programs, and finally I tested GAOS. It is loading very fast. I've never used it on a +4. When I was a kid we had C64. Back then I tested it, but to be honest, it consumed a lot of resources. Instead of that, I played games and wrote some code. Personally, I'm not really bounding to it, but it is good to have. I think with that I'm reaching the end of this video. I hope you enjoyed it. Join me for a few games, and I wish you a very nice day. Goodbye.
Outrun.